Bitcoin was, as I say, an absolutely brilliant piece of computer science that solved a very difficult problem with extreme elegance. Ethereum took what had been developed by Bitcoin and advanced it, made the system faster, better in almost every way, but it's limited. It can only go so far. I don't think that Ethereum ever really expected to have this much uptake. It's, in a sense, a victim of its own success. It simply does not have the ability to scale to the level that it's being asked to scale. So what we try to do with the Geeq project is build on Ethereum, which in turn built on Bitcoin. And we're trying to solve the problems that they left unsolved, just because they were not evident when these protocols were being written. The first, and I think the most important problem that we solve, is the issue of security. So we use two elements in our security protocol. The first is called proof of honesty, which puts the ability of assuring that the blockchain and the transactions are being correctly executed in the hands of the users who would actually suffer if it was not being correctly executed. So we put it in the hands of the people that have the most interest in making sure everything is going correctly. The other is a system of audits through a mechanism that comes from mechanism design and economics. This guarantees that validators will never tell a lie, because even if they were collectively dishonest and were willing to do anything at all without any hesitation and were able to coordinate, still the most profit they could make would be to validate the chain correctly. So this gives us something that we call strategically provable security. It's provable that we have 100% Byzantine fault tolerance, and this generates an enterprise level of security that you simply can't obtain on any other existing technology. That's I think, the most important element. It makes it possible for a responsible company to use blockchain technology. The second is scalability. Ethereum is fantastic, but it simply cannot scale to the point that it's being asked to scale. We're designing Geeq Chain from the ground up so that it can be implemented as a series of federated instances which are, on the one hand, independent. They don't necessarily need to talk to one another, but on the other hand, can be made to be interoperable to whatever degree the application requires. So federated instances are what generate our scalability. The third thing that we're excited about is that we've done this in a computationally light way, so that the cost of validation does not depend upon proof of work, which uses billions of dollars of electricity, doesn't depend upon stakeholders that we have to trust at some level. Ordinary people sitting at home that have a small amount of excess capacity on their home computers can participate as validating nodes and can be paid for the service of participating as validating nodes. So we've set this up to be a computationally light, bandwidth light type of mechanism, so that it sort of democratizes it and lets it become decentralized and widespread and without central points of failure. That code then lets you go ahead and run almost any application you'd care to run. The validation layer runs underneath it on the Geeq coin, and it facilitates the possibility of using blockchain for everything I believe that it was intended to be used for. I'm John Conley. I'm a professor of economics at Vanderbilt University. I've been working recently on the Geeq project, which is a new approach to blockchain.